The double angle formulas are extremely useful, especially when you get into calculus and you do something called integration. They're really useful because there are certain integrals. For example, the integral of sine squared x dx, which if you don't know something called a power reduction identity, I'm not sure how else you could do the integral. So, don't worry about the integral. Worry about just now, how can I take a power of a trig function and switch it into something without powers? So for example, we're going to start by deriving them by using the double angle formulas. Cosine of 2x, and we're going to involve sine in the first one. 1 minus 2 sine squared x. Now, what I want to do is get sine squared x alone. So I'm going to subtract 1 and divide by negative 2. So really what I have here is positive 1 minus cosine of 2x all over 2 is the same as sine squared x. Okay, so whenever I see sine squared x, I can replace it with this, and some books like to write it as 1/2 minus 1/2 cosine of 2x. And all they're doing is they're splitting this fraction up into two different terms. So either way. Alright, I'd like you guys to do the same thing and find a formula for if I wanted cosine squared x, what would it be? So you should pause the video and try it out. Okay, so we know that cosine of 2x is the same as 2 cosine squared x minus 1. Same setup. And we're trying to get cosine squared of x alone. So I'm going to take cosine of 2x, I'm going to add 1 and divide by 2. Okay, that one was a little bit easier. No negatives involved. Alright, and the last one here, you could just write this one down. Tan squared of u. One of them is cosine of 2u all over 1 plus cosine of 2u. So if you encounter tangents, you could use that guy right there. Alright, example. What they'll want you to do is take something like cosine of to the 4th power of x, and their direction will say rewrite in terms of sine or cosine with power no greater than 1. Okay, what that means, I want to rewrite this using trig identities, but I don't want to have any more powers. I want to be able to just have sine or cosines, and like double angles, they're okay. So first thing I would do here is I would rewrite this as cosine to the 4th could be written as cosine squared of x squared. Okay, so it kind of reminds me of when we did double angles, like sine of 4x is really sine of 2 times 2x. Okay, so this here, we're going to substitute right away the cosine version for cosine squared up here. And so one of the easier ways to do this is to butterfly it, so it'd be 1/2 plus 1/2 cosine 2x. Okay. Now I think the next step, the easiest step that would be next, is to actually FOIL that out. We have 2 of these parentheses we have to FOIL. 1/2 times 1/2 is 1/4. Now you're going to do 1/2 times this, and then this times 1/2, so there's going to be 2 of them. So you have 2 1/4 cosine 2x. Okay, and maybe I'm adding a little too many parentheses. It's making it a little cluttered in here. And then lastly, we would do this times this, last times last, which would be 1/4 cosine squared of 2x. Okay, now we can rewrite this. 1/4. 2 times 1/4 is actually 1/2 cosine of 2x. lastly here, I want to get rid of that squared. So what I'm going to do is use the power formula one more time. Now I'm not just going to use the power formula though, I'm going to keep in mind that I have 2x as my argument. And so in my formula up here, I'm looking back here, instead of x I'm going to have 2x, and when I plug it in I'm going to actually have 2x times 2. So probably the toughest part is keeping track of all the coefficients. So this is going to be 1/4, and now the formula is normally the cosine squared of some chunk is going to be 1/2 plus 1/2 cosine of the 2 times the chunk. Let me scoot this over a little bit here. Okay, so since my chunk is 2x, I'm going to have 2 times 2x going in there. So let me write 1/2 plus 1/2 cosine of, and 2 times 2x is 4x. Okay, I got to clean this up a little bit yet. So it's going to be 1/4 plus 1/2 cosine of 2x plus, and then I have to distribute this, so this will be 1/8 plus 1/8 cosine of 4x. Alright, so finally I got to combine like terms, and then I'm going to be done. So 1/4 plus 1/8, that would be 2/8 plus 1/8, so that's 3/8. Plus 1/2 cosine of 2x plus 1/8 cosine of 4x. So it's using the same formula over and over really, and then foiling. We don't have any more powers now, so this is an equivalent expression. So you might think that's a lot. The nice news here is that when you're doing these identities, you can always graph it on Desmos or on a graphing calculator when you're doing your homework, and you can check. So if I really wanted to make sure, I could go back here, I could graph cosine of x to the 4th, and then I could graph this other box one and just see it and make sure that the graphs of each line up.